Yeah, good morning, students. So in the last class, so far in this first module, we discussed about what is the IoT, what is the IoT definition, what are the IoT characteristics, what is the IoT, what do you mean by IoT stack, and what are the different layers. So now it is time to discuss about IoT challenges. What challenges you will face while designing an IoT or implementing an IoT network. So that is, challenges are really many challenges we can face. The challenges are actually not the same for all. It may be different based on the situation and everything and application. So now, whenever we have a challenges, there is some scope we get for the understanding and reading the new things. Okay. So first challenge is the security, personal safety. Security and personal safety of the IoT application. So here the security, data security. What do you mean by security? Means data security. How the data can be secured. Okay. So personal safety, how the person can be safe from the things. So this is the two things we need to discuss in the challenge. First challenge. So here the challenge one is very high rated and most important challenge, because whatever the data the sensor sensed and processor processed, that data should not be tampered by the others. So that it is very important challenge. So here the more number of devices are used in the IoT infrastructure, and this is a challenge. So more number of devices. So now already we discussed about some of the examples like home automation. So in the home automation network, many number of IoT devices are things are participate in the network infrastructure. So that what happened? So there is a how to handle these many devices in the network. So that is the one of the most important thing. And how can you identify each and every device in the network? Of course, we already discussed about this. Each and everything or device or what is it, object which are participated in the IoT network have a unique number, that is the IP address. But anyhow, the handling of all the more number of devices increases, the complexity also increases because of, so that same IoT should handle all these things. Okay, and user data could be vulnerable. So the user data could be vulnerable for theft. So it should be resistant to malpracticing, copying, or modifying. So whatever the data, so the user data is there. So for example, some devices is handling with some other network. Suppose your mobile phone is using for some purpose of controlling the IoT devices. At that time, whatever the device, whatever the data inside your mobile phone or in your memory should not be, I think, so theft or tampered or modified something. So that user data could be vulnerable for theft. That is the one thing. And people's personal safety is concerned and a challenge. Okay, implants and sensors. If you take already I told you, implants are sensors or some devices which can be you can keep them into the patient's body to monitor their health status or to functioning something. So whatever the implants or sensors implanted into the body of animal or the human beings, so that implant should be biocompatible. It should not be damage your health. Suppose if you take iron implant, if you consider iron cassette implant, then iron will get the rusted, and your I think your body will get the infection. So whatever the implants cases, whatever the sensors cases we are using inside the, so for the purpose of biomedical purpose, so those implants should be biocompatible. So otherwise what happened, people or the animals health may get damaged. So this is the another, this is the safety, personal safety. The personal safety is important and data security is important. So whenever you are dealing with the IoT networking, so your data should not be tampered. So whenever the patient carries the implants or sensors, so the patient's body should not be what, so if infected due to these implants or sensors carried inside the body. So that, so the cases of these sensors or implants must be biocompatible. Okay, since many devices are in the loop, one device if getting attacked, the rest of the devices could also be attacked. Yes, for example, in the IoT network, in IoT infrastructure, we have many number of devices, they are communicating each other. Suppose if anybody is tampered the data of one particular device, definitely the other devices may be affected. So that, so the attacking is not restricted to the one device, it may be spread to the other devices also. So that, so try to protect your all the objects or all the things inside the network. So that's why you can in that way you can keep your data, the user data, your data means your user data, more security. And so as I told you, so the persons who carries the implants, the patients simply, so the implant should be made, or the implant cases should be made with the biocompatible. For example, if you go to the some, what is it, especially for example, don't say that means the implants or sensors carried only the very severe health problem patient. No. Sometimes even healthy people also, sometimes what happened, because they have some dental issues. So whenever the dental issues are there, they may be taken implants. So in the place of tooth. So suppose if there is a missing teeth, so then there should be an artificial tooth can be fitted. So the artificial tooth is made with some material. That material should not damage the your health, because it is always in the mouth. So that so always you are eating something or chewing something, and whatever the saliva, you always swallow it. So that whatever the material should not damage the health. So like that, that is one of the best example for the implant. So implant is, don't say inside the body, sometimes in the mouth also we can take it. So whatever the implants we made, we are keeping into the body or into the mouth or wherever it is possible. So wherever it is required, not possible, those must be biocompatible. Yeah. So, and that is one more thing. So, yeah. So poor security features can let the attackers damage the whole network. The security must be, different level of security should be provided for the network. So otherwise, attackers are always ready to what? Attack on the nodes or the devices. So this is the first challenge. Second challenge is privacy. What privacy is? Privacy is one of the challenge. What do you mean by privacy? So privacy is nothing but what? So whatever personal information, whatever the our images, generally we Facebook has a privacy now. So earlier the privacy is not provided. So now, so you can lock your Facebook details. Then what happened? People can see your name and some your image something, but not, they could not go into your profile, like where you are working, where you when you born. So these type of issues, or whatever the photos you have, so whatever the contacts, all the things can be, you can lock it. So that is the privacy. Sometimes we need the privacy. So for privacy purpose, privacy is another important challenge of the IoT infrastructure. You could be tracked or monitored by anyone, as you are connected 24/7 in the internet. Yes, whatever the device, the main device in our hand is our smartphone. So because in the smartphone we have a what is it one one option, that is the location. So with whenever if you switch on the location and you are roaming anywhere, then what happens? Automatically you can be tracked by so any other persons who are having the internet. So that is the main disadvantage. Suppose if you in your mobile phone, if you switch on the location, so then what happened? Wherever you go, so internet follows you and it will track you, so that people easily you could understand where are you. So morning you are in Geetham University, afternoon you are at MVP, something like this. Everything, every details it will be displayed to the others. So that is the one of the problem. So that mostly the people who is carrying this mobile phone, mostly they will switch off the location. So then they will go. So at that time, that because of the location is not switched on, so the tracking is difficult. So you are tracked or monitored by anyone, all over the day. So with the internet, so that is another challenge. You could be tracked without your permission in place. Yeah, you don't know somebody is tracking you, somebody is following you. Okay, so that is the another thing, and another pathetic situation, that nobody, you don't know, without your permission, without your what is that one, knowing. Okay, so you can I think they can follow, they can track you. Yeah, so there is a threat. How do we deal with it? How can we get the privacy? How can we stop it? It is one of the biggest challenge in the IoT network implementation. Okay, that privacy is one challenge, and safety and security is another challenge. And third challenge is data extraction from complex environment. Yes, you need to, but means you need to get the data from the sensor. Sensor is a device which could be acquire the data from the surroundings. Okay, sometimes environment will create a problem in the collection of the data. So generally, if you see what happened, so whenever the rain falls, you could not get your television connection in your home. So because the signals, I think signals, whatever it may be, so they may be get damp. That means they are having some interferences and something, so that simply the network is switching off. So that is the another. That because of in the hard environments, the getting the collection of the data or the signals is somewhat difficult. So how can you extract, or how can you acquire the signals or the data in the hard environment also? That is hard environment or complex environment. Sometimes it is a rainy season, sometimes it is a dead in winter, sometimes it's a deep forest, sometimes it is a cyclone. So a lot of conditions, weather conditions cannot expect, environment conditions also cannot expect it. There may be sudden changes. So in that hard environment, environment or the hard weather conditions, how can you get the data from the sensor is a complex task. Yeah. So how to sense information from the complex environments? For an instance, how to sense the data like temperature, yeah, so temperature, humidity, etc. Those values during the transport from a transport vehicle. Suppose when the vehicle is moving, when the vehicle is in motion, so then, so I think what happened when the vehicle is moving, what happened? So the measurement of the data from the sensors is some. Assume very temperature sensitive material is being transported. Temperature sensitive material means what? So whatever inside the container, that may be the status, what is it one? The state, or what is it one? State of the material or the content may be very sensitive to the temperature. Very sensitive means it changes with the temperature. If temperature is very hot, then it may be spoiled, it may get spoiled. So how can we measure the humidity or temperature of a moving vehicle? So, and this is third challenge. And fourth one is connectivity. As I told you, the connectivity is the main characteristics of the IoT. Connectivity means how the two people can be connected through internet, or through wire, or through any other type of wireless network like Bluetooth, infrared, share it, Zigbee. A lot of things are there. Bluetooth. Okay, so the connectivity, I think fixed connectivity or flexible connectivity. So fixed connectivity means, so always these two devices addresses are fixed and their two devices are always communicating to each other. In the flexible, the address of the devices are changing, dynamically changing. So that the connection, if the connection is strong, then you can get a communication. You will get a communication. You will establish communication. So whenever the network is poor, why don't you get the call? You will get the, why don't you? Why you are getting the interruption of the calls? Because network is not strong. Whatever the cell tower and whatever your mobile phone, both are not connecting, unable to connect each other. So whenever they are unable to connect each other, then what will happen? So definitely, so you will get an interruption. You will get the disturbance. So okay. So that is the, if the connectivity is not so strong, then you will get the devices or the objects or the things whichever participating in the network, they are unable to communicate to each other. So that connectivity is the major challenging task. So provide a better connectivity. Okay, requirement of wired or wireless connectivity, as I told you. So usage frequency spectrum is also be recommended. 2.4 gigahertz band is so used for this purpose. Yeah. The band, whatever the spectrum you are using for that particular application. So that is also important. Yeah. So whatever the number of devices in the world, so which are having the IoT, that means Internet of Connection. So okay, Internet connection. So each and every device can be connected to this. For that, we need to provide the strong wire or wireless connectivity and allocation of the a better frequency spectrum band. Yeah, next one is power requirements. See, the fourth one connectivity, and third one is what? So data extraction from the complex environments, and second one is what? Privacy, and first one is the what? So simple security and personal safety. So these are the four challenges so far completed. Now the fifth one is, what is that? Power requirements. This is very important thing, because all the devices which are working in the which are presented in the IoT infrastructure, definitely they need power. They need power. Some will get the power, wired power. Okay, so some are operated with the battery. For example, if you take your mobile phone, it is operated with the battery. Okay, so the power requirement of the your mobile phone circuits are very less. Then battery life will, so I think more. That means per one day or 2 days or 3 days. Generally, battery power will be measured in the watt ampere hours. Okay, so that the power is very important. So because most of the devices they are participating in the IoT infrastructure are battery operated devices, battery operated objects. So that the battery life is very important here. And the battery life is mainly depends on the how much power they are draining while they are operating or in the sleeping mode. So that's why the power requirement. Because if the power is not there, if the battery is dead, then that particular device will not work. The connection will fail you. Okay, so that the challenging task is the power requirement. Okay, so that all the IoT devices need power. Definitely, whatever the devices working in presented in the IoT infrastructure need the power. So most of the IoT things, that means the things which are participating in the IoT circuit are working with the only battery. So okay, so generally you can imagine one more thing. So as I told you, the implants, bio implants, or the sensors, sometimes most of the, I think in the world, whole world, if you consider, so billion of people are having the implants inside their bodies. So whatever the implant, whatever the sensors inside the body, they must be live. Okay, for what? Collecting the data inside the body, and so do the necessary actions, commanding signals, and do the better function. Okay, understand? For example, for suppose in the body, one implant is or one sensor is placed inside the body for not functioning, for proper functioning of the some blood vessel. So it will sensor will always take the data from the blood vessel. If it is good, no problem. If it is not good, that means it's flowing the less amount of the blood. Then, so what happens? Some control action will be given based on that. So it will be widened and more blood will flow. So that type of actions will be taken there. So since the entire system, small system, of course, entire system is inside the body, you cannot provide external power supply. So that at that time, how can you charge up your battery inside the battery inside the system? I think so. In such a cases, the battery is a long run battery, so that the circuit whatever it is having, so inside the system, that will take very nominal power, so that the power consumption is very small. Hence, the life of the battery is more and more and more. So that, yeah, suppose if you think about 1 decade or at least 5 years or 6 years back, whatever the mobile phones you have, so their battery capacity and today's battery capacity, you can compare. So those days the batteries generally, if you charge your mobile phone morning, maybe afternoon or evening it may be dry. So again you need to charge up it. But today's, if you charge once fully, then so it may be run for 2-3 days without charging up. So that is the case, because we are going to implementing the, we are going to, so increasing the, we are going to towards the increasing the battery life, as well as the amount of the power consumed by the what circuits in the mobile phone also decreasing. So these two are, one is rising, one more is decreasing, so that compensating, so that automatically the power requirement of the particular circuits are decreasing, thereby the life of the battery has been increased. So that power requirement is very important thing. Okay. However, demand for power is ever on the rise, and use of green power sources like solar, wind is to be motivated. Yeah. So I think if you understand, for example, so power is required, as we discussed in the sometimes when they are working in the outside environment. So why don't they get charged up with the solar power? Because it is already the particular node or particular device or particular thing is there, so that whatever the available power, so from that it can be automatically charges. If you keep such type of what is that one, so mechanism, if you provide, so then automatically the power requirement, power, what is that one, power is the battery life is more and more. So that is the another thing. So that power requirement is another challenging. And sixth challenge is complexity involved. Yes, complexity means what? The size. When the size of the infrastructure, IoT infrastructure increases, definitely the number of devices increases. Then the handling capacity also need more and more things. Like, so many devices means many issues. Okay, so that complexity involved. So here, so IoT is not easier. So why means need lot of different domains to come together. Yes. So as I discussed with you, so IoT is not a single technology. So it works with the many different technologies, many different domains. Technology and domains are different. So IoT is able to work with many kinds of technologies and domains, so that it's not the single one. So limited expertise in the market. So I think expertise is very limited, not full expertise. That means we still, you can say, very fundamental things, very basic things we are doing with the IoT, not very complex things we are not unable to handling this. So because of that one, so that is more expertise is required. Experts are required. The toolkits, softwares, hardware not abundant. So we need the awareness, lot of things. Okay. Next challenge is cloud. Seventh challenge is cloud storage. So where you can keep all the data. So because, so suppose for example, if you keep one camera inside your home to monitor, okay, for surveillance purpose, so that how much data, how many number of days data it can be stored, that is difficult, because the storage is always the memory, whatever the memory chip or storage device or storage chip you kept in the along with the camera is limited. Okay, at 1 day, 2 day, because it's continuously monitoring and storing, na? So that 1 day data can be stored, so second day, third, like the up to 15 days or 16 days data can be, I think, handled. After that, what happened? The first data will be erased, and this data, today's data will be loaded, stored. So like that, it will be going on. So that is, the storage is not infinite; it's a limited. So because we have a limited memory resources, we cannot store much more data because of 24 hours surveillance cameras are always having who's are handling with the whose amount of data. So that whose amount of data you could not be able to store in a particular hardware device. So we need to go for the cloud storage. Yeah, cloud is being mandatory for storage. Yes. So problem is which cloud is used. As I told you, cloud. So cloud is a software memory device, I told you. So we have different cloud. As I told you, you can use the cloud as the application software. Okay, as software, SaaS, AS, and what is it? So you can use the your what is it one, your cloud, whatever the cloud you have, service. You can use the service. Okay, some you can use the software also. You can use it for the applications also. Yeah, like this, different things are there. Okay, anyhow, the cloud. If you want cloud area, a space in the cloud, then we need to purchase, or we need to get from the service providers. As I told you, we have Azure, Amazon, sorry, yes. So these are the Google, these are the some of the service providers that provide the cloud. So how to identify? Yes, whenever you are connected with the cloud, how can you identify how much cost this cloud? So do we really need cloud? Yes, these are the things. Yeah, these are the 7 challenges. Once again, we will discuss about the challenges. 7th one is storage, and 6th one is complexity involved, and 5th one is the power requirement, and the 4th one is the connectivity, and 3rd one is data extraction from the complex environments, and 2nd one is the privacy, and 1st one is the what? So security and personal safety. So these are the 7 challenges you need to face. So while you are implementing the IoT networking. Okay. So next one is levels of IoT. So we have number of levels. Level 1. Okay. So with the amount of complexity involved, one could categorize IoT as IoT levels. Simple, first level, somewhat more complex, second, more complex, third. Like this, we have a 6 levels. This is based on the number of devices are participating simply. So here, if you take this picture, this is the air conditioner, and this is the temperature sensor, and this is the data collection and analysis, and this is your mobile phone or monitoring action on off control switch. This is a mobile phone simple. So this air condition, okay, so I think it is switched on. Based on that, this temperature sensor will measure this temperature, and it is displayed on this data collection unit, and then it is supplied to this controlling and monitoring device. Then if the temperature is enough, actually according to the reference value, then it's okay. Otherwise, it may be either increasing or decreasing action it will take, or it can be, you can on and off it. So start with the simplest of levels, level 1. So what can be this? Have one sensor, device to sense. Okay, so that is the sensor or the pressure. The data to be stored in locally. That main thing is data. Where the data of the sensor will stored. I think there is some very small amount of the data. Memory is required so that you can handle it locally. And data analysis is also done. Monitoring control can be done through the application. So .apk or web apps, you can take anything. This is the level 1. Okay, this is used for simple applications. with limited complexity or no complexity. I think in this picture, in this level, as I'm showing the picture, in this picture does not have any complexity. So because very simple, AC, temperature sensor, data analyzer, and so monitoring device and control device. So data is not whose, means not a big data here. All the control happens to the internet. Yes, second level is this is second level. In the second level here, the data is definitely voluminized. So that means data is more, not as in the level one. So data capacity, data amount of the data is more than the first level. Means the frequency of the sensing done by the sensor is faster. Earlier only the sensor will data is very small, because just it will take the data and it will make the comparison, and so based on the comparison they will provide the control action. But here the data is a little bit more than the earlier one, so level one. So that the sensor, when the data is used, the frequency of the sensor done by sensor is sensing by the sensor is faster. That means rapid movement of sensor is there. So that is the yeah. So higher cloud storage is preferred, because when the data is more, you can go for the cloud storage. Okay. So analysis done locally. Cloud means for the storage alone. Okay. So based on the data analysis, the control action can be triggered always. So the data which was supplied by the sensor is analyzed and given to the mountain device, where it can be compared with the so reference value. Based on that, so based on the error, they will take the action. Okay. Some example counts are agriculture applications. Okay. Room freshening solutions based on the odor, etc. So these are the some of the. This is the sensor. Sorry, AC. This is your sensor. Okay. And here you can take the data analysis. Then so the data is now in this case is a bigger. For example. Okay. So then you need a cloud to store it data, and then yes, controlling or monitoring device. This is the level one. So in the level one, since the data is more than the level one, we need a cloud. Yeah. Yes. Next one is level three. Level three. So in the level three, what happened? So in the level two, there is only cloud, but now is the cloud is including with the data analysis. Okay. So that is the difference. See, this is the first level, the second level. So here is there is a big data, bigger than level one. Data analysis done locally, but in the third level, the data analysis is done in cloud, not in local. Yes, the data is definitely voluminous. So frequency of the sensor is faster, and is faster. So this is preferred, and analysis done in the cloud, not in the local. So based on the data analysis, the control action can be triggered by using either web apps or mobile apps. You can take anything. So examples is agriculture applications, room freshening solutions. So like this. Next one is level 4. So in the level 4, what happened? More number of sensors data is collected. Yeah, this is the temperature sensor, and this is the cloud. You can store it. So temperature sensor will sense the temperature and store in the cloud, and in the cloud there is a data analysis will take place, data collection and analysis will take place. Then there is a what controlling or controlling devices there. That is the web apps or mobile phone apps are using. So another another is sensor is also you can connect to this one. This is the moisture sensor, and there is a pressure temperatures like this. Different kinds of sensors are connected with the cloud parallelly, and those data is analyzed and is supplied to the control or monitoring mechanism. Then they will take the based on the error, they will take the patients. So this is the here if you see in the level 1, level 4, complexity is increased, and there is a many number of sensors are there. So all the sensors data is collected by the cloud, is sent to the cloud and analyzed in the cloud, and then sent to the what is that one monitoring device or control device through web apps or mobile apps. Okay, so this is there is a data is definitely voluminous, means the frequency of the sensing done by sensor is faster. Also multiple nodes, each sensor you can say one sensor node. multiple nodes are there and are independent of each other. So there is no dependence of each and every sensor. Okay. Also, they upload data to the cloud, means all the sensors as shown shall upload the read sensory inputs. So the cloud storage is preferred because the data size is more, and analysis is done in the cloud only. Application is totally cloud based, and based on the data analysis, analyzed data, the control action can be triggered to the web apps or mobile apps. This is the level 4. Level 5 is, see, this is the temperature sensor, this is the moisture sensor. Just like this, 3 nodes are there, and then there is a all this data is collected by the cloud. Sorry, coordinator node. Yeah, one more node is required. These are the local nodes. This is the global node. See, temperature sensor is one node, moisture sensor is one more node, pressure sensor is one more node. So all this data is given to the coordinator node. That is called the global node. So then this global node, from the global node, what happened? Your cloud will take the data, and where data will be analyzed, and the analyzed data is supplied to the monitoring device. There it will take the control action. This is the level 5. In the level 5, what happened? The coordinator node is included. This is the, you can say this is the parent node. Parent node. So whatever the sensor data, they can be channelized to this node. Yeah. So like that, we have 5 levels. Okay. So in the first level, simple. What is IoT? Only a single node. So no cloud. Okay. The cloud is used, but data analysis will be locally done. And in the third level, data will be what is that one? Analyzed in the cloud only. And in the fourth, so parallel sensors, multiple nodes of sensors are using. And in the fifth level, so multiple sensor nodes along with one parent node or coordinate node is using. So this is these are the differences, different levels. Yes. So what have we understand? So I think sense transponder. See here in this picture, this is the sensor. So I think whatever the car is there, it has a sensor and IoT networking, so that it will send the data. Okay, wirelessly. This transmitted data is received by this transport. This is the antenna which can be used for both receiving as well as transmission. This transmitted data will be stored in the cloud. This data again collected by is sent to the or received by the analyzer to analyze what kind of data it is. Based on that, some control action will be supplied. Thereby, the control action will be done, and so thereby, what happened? This sensor, whatever the mechanism inside the car, will be controlled. That is the simple thing. First, car is having some kind of IoTs, okay, some kind of IoTs for particular tasks. So that what they are doing usually means they always I think transmit the data from the sensor node. Okay, collected data is transmitted. So the transmitted data is collected by the transmitter network or the antenna, which can be received as well as transmitted to the storing purpose to the cloud. Then for an analyzing device will take the data from the cloud, and it is analyzed there after analyzation. So what happened? The error signal will be generated. Based on the error, the control action will be takes place. So very simple. Like this, most of the IoT devices are working. Yes. So now after study of all this entire first module or first unit, at last I have a small doubt. What is it? What is the difference between the cyber physical system (CPS) versus and IoT and cyber physical system? How can you distinguish both of them? That is the one question. So because we always talked about the IoT, but cyber physical system we never talked about. But so if it is time to understand what could be the difference. Generally, CPS is mainly concerned about the collaborative activity of sensors or actuators to achieve certain goal, and to do this CPS uses IoT system. Yes. IoT, cyber physical system are not the same. Both are different. Both are different. Okay. So cyber physical system uses IoT. Okay, but it is not complete IoT. Cyber physical system is mainly concerned about the collaborative activities. So number of sensors or actuators are there. So with all this, it is meant for one common goal. All the sensors or actuators working in the cyber physical system are working towards a common goal. Okay, a predefined goal. So that is the cyber physical system. Okay. CPS is not IoT. Yes, I clear it. So IoT is one of the component of CPS. In CPS, IoT will be used, but it is not alone. Okay, there are many other things also there. So that you can't say CPS is the IoT. Okay, IoT is one of the component of CPS, cyber physical system. CPS is very complex. IoT is a simple device, of course, but CPS, cyber physical system, is a very complex device. Okay, so and the implementation of the CPS is very intelligent, very challenging task. Okay, so it is a cyber physical system is a combination of many engineering disciplines like computer engineering, electronics engineering, electrical, mechanical. All this combination is nothing but CPS is working. CPS is expected to be more brilliant and autonomous and taking the appropriate decisions as and when needed. Yes, CPS is a complex system, and more intelligent system and more autonomous. It's not depends. Okay, and it is taking the appropriate decisions. It will take the appropriate decisions when, as and when needed. Okay, it should not be wait for others' commands. It should not wait for others' permission. Simply CPS is working together like that. So it is a complete one brain. So it is having its own powers. It can do the things. So based on the situation, it should be work. But IoT is not like an intelligent system. It is simply what kind of data they are supplying, sensors. So that's that data will be analyzed and so sent to the control signal, control mechanism. That's it. So if the data is not good, don't worry. It will not take any problem. It will not, it will not think about that. But in the CPS, cyber physical systems, so the data, whatever the data they are receiving from the different sensor nodes or different things, what happened, they will be analyzed. If the data is not good, so again they will take to adjustment, go for the adjustment. Okay, for better collection of the data. Okay, that is the CPS, cyber physical system. Okay, so finally I can conclude that CPS is not the IoT. IoT is one of the component of CPS. Okay, so that is, and in this first module or first unit, the last topic we need discuss for the discussion is IoT versus WSN, wireless sensor network. Wireless sensor. So in the earlier case, we have an example in the cyber physical system. I think your racket is a one of the cyber physical system. So it has IoT devices also, but many other devices also there. Okay, so whenever the racket is going based on the I think started. So then based on the climatic conditions, based on the environmental conditions, it will take the decisions. It will take the decisions, own decisions. So, but IoT is not like that. It cannot, it could not be taken own decisions. Whatever the intelligence we provided, it will work that intelligence only. So, in this first unit, at the end, we can discuss about the IoT versus wireless sensor network. What is the wireless sensor network? See, whenever you are going for the complex IoT, means more number of sensors are there. Okay, more number of sensors are there. Then how they can be communicate each other? How can be communication is established? So that is the some kind of devices there. If they are wirelessly connected, so then you can say that is a wireless sensor network. So wireless sensor is a network. A network is a built with multiple autonomous sensors. Okay, and all the sensed data are passed through the certain located server. Okay, certain centrally located server. Sorry. Okay, so this is as we have taken the example of level 6. Sorry, level 6. What happened? So there are many parallel sensors out there. So those sensors we can say them as a local nodes, and the data is collected, is sent to the global node that will be channelized this data and is sent to the cloud. So like that. So there is a parent nodes and children nodes are there in the network. Okay. So the parent node is important thing. Okay. So these are the I think this is the first ending of the first unit. I hope you understand, and need to share one more thing. 1 minute for simplicity. Yes. Yeah. See this one. Are you able to see this? My screen. Now I changed the content. Students.
Yes, sir.
Yeah, here you can see this one. This is the wireless sensor networks. These are the different nodes, sensor nodes. Okay, all these sensors are connected through some wireless connectivity, and this is, see, this big circle, green circle. This is the what master node or parent node, or sometimes you can call it as a gateway. So all the information of the sensors are passed to the this main sensor node. Okay, this is the master sensor node or the parent sensor node. So like we have a different things. So otherwise, this is the person we need to communicate with all the cells means. So they, if they are sending parallelly, then this person will confuse. So that, so whatever the data, whatever the each and every node must be followed through the, so send the data or pass the data through the this gateway sensor node. Okay, understand? This is the wireless sensor network. So the sensors are working like this. So this is the local sensors. This is the global sensor. You can say, you can call it. Okay, understand? Yes. Yeah.